Hello everyone, this is Simple Math for you and our lesson today is Arithmetic Sequences. أهلا بكم في Simple Math for you ودرسنا اليوم هو عبارة عن المتتاليات الحسابية. Let's start. What is a sequence? A sequence is a set of numbers that are ordered in a specific way. المتتالية هي مجموعة من الأرقام أو من الأعداد المرتبة بشكل معين. Each number within a sequence is called a term of sequence. In an arithmetic sequence, each term after the first is found by adding a constant. For example, this is called arithmetic sequence. Why we call it arithmetic sequence? Because the difference between two consecutive terms is constant. So the first difference, let's say that the first difference is 17 minus 22, which is negative 5. The second difference is 12 minus 17, which is negative 5, and etc. The difference is constant, and we call it the common difference D. So in our case here, the common difference is negative 5. For example, there are some sequences, but they are not called arithmetic sequence. Let's say we have here 2, then 4, then 8, then 16. We can expect that the coming number or the other term here, the next term, is 32 because each term is coming after multiplying by 2. 2 by 2, 4, 4 by 2, 8, 8 by 2, 16. So 16 by 2 is 32. However, this is not called arithmetic sequence because in arithmetic sequence, we are only depending on the constant difference. Here, the difference is constant as well. Here, D1 is negative 5 minus negative 13, which is 8. And it's very obvious here that the terms are increasing by 8. This is called term 1, this is term 2, this is term 3, this is term 4 and etc. We call the term A, determine to be easy for everyone. So this is a quick and simple idea about the arithmetic sequence. Let's now solve these exercises. Determine whether each sequence is an arithmetic sequence. Justify your reasoning. Is this arithmetic sequence? To check or to justify, we will find the difference between two consecutive terms. So the first difference is 1 minus minus 3. Remember that this is A1, A2, A3, A4. When we are finding the common difference, we are not finding A1 minus A2. We are finding A2 minus A1. So it's 1 minus minus 3, which is 4. And it's obvious that the terms are increasing by 4. From minus 3, it's added 4 to become 1. Let's find D2. D2 is 5 minus 1, which is 4. D3 is 9 minus 5, which is 4. As you see here, the differences are the same. So in this case, we can say, yes, this is an arithmetic sequence. Let's check the next one. We have here 1/2, 3 over 4, 5 over 8, 7 over 16. Let's find that first difference. First difference is 3 over 4 minus 1 over 2. We can know mentally that it is 1 over 4. If you don't know how to find it mentally, simply you can use the calculator. So it is 3 over 4. We go to this button, 3 over 4 minus 1 over 2. So it's 1 over 4. Let's find the second difference. Second difference, 5 over 8 minus 3 over 4. 5 over 8 minus 3 over 4. And let's do it here. negative 1 over 8. It's very obvious that the difference is not constant, so no need to check the next terms, since difference 1 is not equal to difference 2, so it is not an arithmetic sequence. Find the common difference of each arithmetic sequence. Now, for the coming questions, it's already given that it's arithmetic sequence, so we will not check, we don't need to check each difference. So we just find the common difference 1 by subtracting any two consecutive terms. ممكن نشيك أي ترمين متتاليين. So we can find this difference. So this difference is 1.08 minus 0.02. And you can use the calculator, which is 1.08 Now, can we find the next three terms? Yes, we know that the last term here given 3.2. So the next term, so this is A1, A2, A3, A4. So A5 is 3.2 plus 1.06, and we will find it. How much? Check with me. 4.26. So A6, term number 6, is 4.26. The last term we have got plus 1.06. It is 5.32. And now A7, term number 7, 5.32 plus 1.06 is 6.38. So these are the next three terms that we can find. Next question here, we will find the difference between two consecutive terms. Anyone you can find between this and this, or between this and this. Let's find between 113 minus 7 over 12. 1 and 1 over 3. So we can use the calculator. When you want to use a mixed fraction, press shift this button. So 1 and 1 over 3. Minus, what is the second term we want? 7 over 12. So it is 3 over 4. Now we can add 2 and 5 over 6 plus 3 over 4 to find term number 5. And also you can use the calculator as we know. So we can find 2 and 5 over 6 plus 3 over 4 then the next term, term number 6, the final term, again we will add 3 over 4. It will be 4 and 1 over 3. Then term number 7, 4 and 1 over 3 plus 3 over 4. Five and 1 over 12. So these are the terms that I am looking for. Now let's do part 2 here. Check arithmetic sequence as linear function. Each term of an arithmetic sequence can be expressed in terms of the first term A1 and the common difference D. And this is very important to know the nth term of any arithmetic sequence with the first term A1, the common difference D, is given by this equation where n is a positive integer. Why we are using this function or this equation? To find any term. Let's say we want not the 6th or the 7th term. We want to find term number 100, term number 200. So it is not a practical way just to add each time. We are going to use a function or an equation to replace and find this specific term. Use the given arithmetic sequence to write an equation and then find the 7th term. Let's see here how can we use it. We have the equation an is a1 plus n minus 1 d. So we need a1. a1 is the first term. So an is a1, which is -3 plus n minus 1 times d. d, as we know now, which is the common difference, which is -8 minus the -3. Sometimes you can do it mentally. So it is -8 plus 3, which is -5. So I will replace -5 here. Then I will simplify as much as I can. So I will distribute -5 times n, -5n, -5 times -1 is +5. We have here an is equal to -5n, -3 plus 5 is 2, like terms added, and this is the simplest form that we can have here. Now we will find out the corresponding term or the required term that he asked for. So we want, for example, term number 7. So I will replace n by 7. If he wants term number 100, I will replace n by 100. So it is -5 times 7 plus 2, which is -35 plus 2, which is -33. So term number 7 required is equal to -33. Perfect. Let's see this sequence, arithmetic sequence, and we will find also d. We need d. d is -0.5 minus -0.75. Remember, term 2 minus term 1, not the opposite. So we will subtract. How much? You get it? Perfect. And it is very obvious. It can be found clearly mentally. And then we will replace an is equal to a1 plus n minus 1 times d. So an is equal to a1 is the first term, n minus 1 times d, which is 0.25. And we will also distribute 0.25n minus 0.25. So it is 0.25n, and this plus that, it is -1. It's very clear, it is -1. So this is an. And then what? Then we will find out the required term, and it is required to find term number 7. So I will replace n by 7. So it is 0.25 times 7 minus 1. And it will give us 0.75. Let's check whether we can find it mentally. As it's obvious here that the numbers are increasing by 0.25, which is the common difference. So let's try to add 0.25 each time. This is term number 1, term number 2, term number 3, and this is term number 4. So if you add 0.25, term number 5 will be 0.25. Term number 6, it will be 0.25 plus another 0.25, it will be 0.5. Term number 7, adding 0.25 to 0.5, it will be 0.75, which is the term that I found here. So yes, we can check mentally because it is very near, but if it is very far, it is taking time consuming, so it is recommended to use the equation, of course. Randy has been training for a marathon, and it is important for her to keep a constant pace. She recorded her time each mile for the first several miles that she ran. At 1 mile, so term number 1, her time was 10 minutes and 30 seconds. Since it was mixed the minutes and the seconds, we will convert the seconds into minutes. And everyone knows that 1 minute is equal to 60 seconds. So that means 30 seconds is just 0.5 minute. So the first term here, it will be 10.5. The second term will be 21 at 3 miles, which will be 31.5 also. The fourth term will be 42 miles, etc. Write a function to represent her sequence of data. Use n as the variable. So we will do what we have done before. An is equal to a1 plus n minus 1 times d. So an is 10.5 plus n minus 1 times the d. How much is the d? It's the difference between these terms. So our d is 21 minus 10.5, and it is 10.5. So by chance, it is equal to the first term. Now let's distribute 10.5 plus 10.5n minus 10.5. It's very obvious here that this cancels that. So an in our case is 10.5n only. Now we will use this equation to find out how long will it take her to run the whole marathon. Round your answer to the nearest thousands if necessary. The marathon is 26.2 miles. So we will imagine that we are finding term number 26.2. I know it doesn't make sense that time, but it is at mile number 26.2. So I will replace n by this number. So it is 10.5 times the 26.2. I'm using this equation, remember. So I will use the calculator. 10.5 times 26.2. It is 275.1. That's it. Minutes. Sorry, seconds? No, minutes, yes, minutes. We can convert it to hours. Let's see this real-life application. A theater has 20 seats in the first row. We have 20 seats in the first row, so this is number 1. Seat number 2, it has 22 rows. Seat number 3, 24, etc. Until term number 25, or row number 25. So when you want to create the function, an is a1, which is 20, plus n minus 1 times d. Our d here is very clear that it's 2. It's 22 minus 20, which is 2. And our function will be 20 plus 2n minus 2 by distributing, which is 2n plus 18. Knowing that this and that are like terms, 20 and minus 2. So this is your an. Now graph the function. To graph the function, we don't need even to follow the equation or the function. We know the sequence. So term number 1 was 20. So I changed the scale using multiples of 4. So term number 1 is 20. Term number 2, 22. Term number 3 is 24, etc. And it is very obvious that it should be linear pattern. All the arithmetic sequence functions or the arithmetic sequences represent linear functions, linear pattern. So you can continue and plot the rest of the points. How many seats are in the last row? He said that we have 25 rows, so our n is 25, and I need to find a25, which is a1, which is a1 plus طبعا n minus 1 d. So I will replace every n by 25, every d by 2. We found the d2, and the a1, which is the first term, which is 20 here, and this is 20. So it is 20 plus 24 times 2, which is 20 plus 48, which is 68. So we have 68 rows, and you can check by counting. Let's see this question. Determine if the sequence 1, 1, 1, 1 is an arithmetic sequence. Explain your reasoning. Now, the condition or the definition of the arithmetic sequence says that if the difference is constant, then yes, it is arithmetic sequence. Is it? Let's check. What's the difference between 1 and 1? 0. 1 and 1, 0. 1 and 1, 0. So in this case, according to the definition, yes, it is, because the difference is constant. Okay, if you try to plot it, it will be a function, linear function, but constant at one. First term, second term, third term. So it's a horizontal line. Find the value of x. That makes x plus 8, 4x plus 6, and 3x are the first 3 terms of the arithmetic sequence. So this is the list that we should have. We want to find x. From the definition, by the definition of the arithmetic sequence, the difference should be constant. So if this is term number 1, term number 2, term number 3, and it is an arithmetic sequence, then A2 minus A1 should equal to A3 minus A2. This difference should equal to this difference, right? And we will find it. Now, A2 minus A1 is 4x plus 6 minus x plus 8. And we will simplify. 4x plus 6 minus x minus 8, the minus distributed. 4x minus x, 3x. 6 minus 8 is negative 2. This is number 1. A3 minus A2, A3 is 3x. Minus A2 is 4x plus 6. So it is 3x minus 4x minus 6, which is negative 6, negative x of 1 minus 6. So now we have to make them equal to have an arithmetic sequence. Solve the equation with variable in each side. So here we have 3x plus x equals 2 minus 6. 4x is negative 4 and x is negative 1. So this is the value of x. That was for arithmetic sequence, and this was the lesson for today. Thank you all and goodbye. أشكركم على حسن استماعكم وإلى اللقاء.